on C1 or C2. So let f of z is the function be analytic on C1 and C2, and throughout the region and throughout the region between the two circles let z be any point in the ring shaped region, ring shaped region between the two circles, ring shaped region means this region between the two circles C1 and C2. Then f of z is equal to sigma n runs from 0 to infinity a n z minus a whole to the power of n plus sigma n runs from 0 to infinity. This is not n runs from 1 runs to n runs to 1 to infinity bn by z minus a whole to the power of n. This is equation 1. Where an is equal to 1 by 2 pi I integral over C1 f of z dash by z dash minus a whole to the power of n plus 1 dz. This is our equation number 2, and bn is equal to 1 by 2 pi I, the same. This is the integral over C2. This is the closed contour we are taking. C2 f of z dash by z dash minus a whole to the power of minus n plus 1. This is only the difference. dz dash. F of z dash we are taking z dash. This is equation number 2, where the integration taken around C1 and C2 in anti-clockwise anti-clockwise sense direction. This is called Lorentz series expansion of f of z at z is equal to z naught. The proof of the theorem is not necessary. Only in the examination, write down the Lorentz series expansion or Lorentz theorem. Like that, it is given. Just you write down this statement. If you write this statement, that's enough for. It is not necessary to prove this one. Okay. But whereas we solve the problems by Lorentz series expansion, we differently we go. That is I will discuss next. That is you write down from the theorem Lorentz series theorem. Here from the theorem means a Lorentz theorem. From the theorem, the curve C is same in both integrals. In both integrals. What integrals? These two integrations. You see, integration of C1 and integration of C2. These two integrations, the curve C is same in both integrations. This means we notice that Bn is same as An, where n replace by minus n. అంతే అదొకటే మనకు చేంజ్ వచ్చింది. n replaces by minus n. Okay, so therefore what we do, we want to find the Lorentz series means if you find the An means automatically you will get the Bn also. Thus we Okay, ma. Sorry for the interruption. ఉంటారు కొంతమంది విధవాళ్ళు ఉంటారు, చేస్తా అంటారు ఇదే పనిగా. Okay, so from the above theorem, the curve C is same in both interval integrations. This means that an and bn are same, just the difference is only the n replaced by minus n. Okay, therefore we rewrite the Lorentz theorem as f of z is equal to n runs from minus infinity to plus infinity an into just simply z minus a whole to the power of n. That's all. That bn is not necessary. So here only we'll get everything. So what is an here? Where an is equal to integral over c, curve c, integral over c, f of z. I'm writing f of z, z dash instead of I'm writing just simply f of z by z minus a whole to the power of n plus 1 dz, n plus 1 dz. So this is the integration. This is a Cauchy's integral theorem. You see that the same thing we are taking, integral formula there. We are taking the same thing here. Z minus a, z minus z naught whole to the power of n plus 1 dz, integral over c. So therefore that means what? F of z is analytic on and within C1 everywhere, then the Lorentz series expansion of f of z in power of z minus a is just, it's a Taylor series expansion only. Simple ga Taylor series expansion em teeskuntamo ade vastadi meeku. So it is coming from the Cauchy's integral theorem. Okay, so now I will discuss some problems on this one, then you will understand how can you solve the problems by Lorentz theorem. Example 1. Given two Lorentz series
Someone's previous sides. Okay, sir.
Lorentz series expansions in power series, in otherwise in powers of z for f of z is equal to 1 by z square into 1 minus z and specify the regions in which these expansions are valid, in which these expansions are valid. So many times asked in the examination this. Otherwise, we can simply write this as find the Lorentz series for f of z is equal to 1 by z square into 1 minus z, and find the region of convergence. Find the region of convergence. This is so many times asked. Not only like this one, the same problem asked in find Lorentz series expansion, LSE I am writing, for f of z is equal to 1 by z square into 1 minus z, and also find the region of convergent, where the function is converging. So what is the limits between we write this function as a Lorentz series అనేది మనం find out చేయాలి. Interval we want to find. Okay, so here you see simply I will solve this particular problem. The solution is given that f of z is equal to 1 by z square into 1 minus z. It has so how many singular points we have for this function? Singular points ante ekkada the function is not analytic ante danni singular point antamanesi nenu first class lo cheppanu. If the function is not analytic at that point is called the singular point. Okay, ikkada chudandama, if you put z is equal to 1, then 1 minus 1 is 0, means the function is not defined at z is equal to 1. That means the function is not analytic at this point 1. So therefore 1 is the singular point. Not only 1, if suppose you substitute z is equal to 0 also, then 1 by 0 you are getting. That means it is not defined, the function is not defined and not analytic at that point. So therefore these 2 points are the singular points. So it has 2 singular points. So z is equal to 0 and z is equal to 1. Just మనం చెప్పాలి అంటే అక్కడ నాట్ అనలిటిక్, the function analytic కావాలి తప్పకుండా Lorentz series రాయాలంటే, but it has 2 singular at this point and this point it is not analytic. It is not analytic, it is not defined, the function. Okay, 2 singular points, that is I want. Now I will expand after that. So f of z is equal to, can I write like this one, 1 by z square into 1 minus z as, I will write as 1 by z square as it is I will keep, and this 1 minus z I will write as 1 minus z whole to the power of minus 1, whole to the power of minus 1. So we know that by the Maclaurin series expansion 1 minus z whole to the power of minus 1 can we write as minus 1 plus z square plus z cube plus z power 4 plus and so on, like that one it will come. So therefore z square into 1 plus z plus z square plus z cube plus and so on. This is so this is valid for if Z is not equal to 0, definitely, and mod Z is less than 1. Mod Z is less than 1. So mod Z is less than 1 means what? It is a circle with a center at 0. Z is equal to 0. At that point, the function is not analytic, and with the radius is 1. If we consider 1 at 1 also, it is not, the function is not analytic, therefore less than 1. Mod Z is less than 1, we consider. Okay, so this is equal to I will write like this one: Z square plus 1 by Z plus, this is Z square by Z square is 1 plus 1 by Z again. మళ్ళీ వచ్చిందా 1 by Z, అంతే కదా. Z by Z square means 1 by Z plus 1 plus sorry, Z cube by Z square means what? Z only. And so on. This is the way the series is going on. The series is going. Okay. So this is, I will write in the 1 minute. చెప్పు. వెరీ గుడ్. ఓకే ఓకే రైట్. మరి నేను క్లాస్లో ఉన్నా, క్లాస్ కాగానే ఫోన్ చేస్తాను. This is, I am writing in the sigma notation. Sigma n runs from, you see, 0 to infinity. The total series I am writing as z to the power of n minus 2. You see that n is equal to 0, then it is a z to the power of minus 2. This is valid. 1, then this is valid. 2 minus 2 is 0, then it is 1, it is valid, and plus z, and so on. This is, so this is valid for only 0 less than mod z is less than 1. Mod z is less than this is not 0, so therefore z is not equal to 0. So therefore definitely this function is valid for 0 less than mod z less than 1. This is the region of convergence. This is the answer. That's all. The next problem, expand f of 1 by z square minus 3z plus 2, 1 by z square minus 3z plus 2 in the region in the region 0 less than mod z minus 1 is less than 1, Okay. Number 2, 1 less than mod z less than 2. Mod z less than 2. So many times asked in the examination. Very simple problem. So many times came. The solution is, so ఇక్కడ చూడమ్మా, I will write the function f of z is equal to 1 by z square minus 3z plus 2 as, can I write like this one, z minus 1 to z minus 2, z square minus 3z plus 2. So you take the that factor minus b plus or minus under root of b square minus 4ac. By that one you can find the two factors, those two. Otherwise you can write minus 2 minus 1, minus of minus plus minus 1 z minus 1 minus 2 is z minus 2. This is the way also you can write. And this is I will write like this one. You see, z minus 1 minus z minus 2 by z minus 1 z minus 2. చూడమ్మా, z minus 1 minus z plus z cancel. This is minus 1 minus of minus plus 2, minus 1 plus 2 is 1. సరిపోయిందిగా. So therefore this is equal to 1 by z minus 2 minus z minus 1 by these two, z minus 1 cancel, 1 by z minus 2, and z minus 2 by these two, and z minus 2 cancel, 1 by z minus 1. Because so how many singular points for this function? So z is equal to 1 and z is equal to 2 are the singular points of f of z. At that point the function is not analytic. Number 1, the function f of z, the function f of z is analytic అందుకోసం ఇక్కడ ఏముంది చూడండి అమ్మా, లెస్ దాన్ 1 ఉంది చూడండి, 1 less than mod z less than 2 ఉంది. Analytic in the region zero less than r2 less than mod z minus 1 less than r1 less than 1. ఎందుకంటే you see here for this one, this is given 0 less than mod z minus 1 is less than 1. We put z minus 1 is equal to w. In the previously for Lorentz series, how we did the same way we are writing here. This implies z is equal to what? W plus 1 and w plus 1 and z minus 2 is equal to z minus 2 is equal to from this only I'm converting. So implies z minus 2 is equal to w plus 1 minus 2 okay. This is equal to w minus. So put z minus 1 is equal to w and z minus 2 is equal to w plus 1 అంటే z is equal to w plus 1 వచ్చింది కాబట్టి w plus 1 minus 2 కాబట్టి w minus 1. సో z minus 1 w అయితే z minus 2 w minus 1 అవుతుంది అంతే కదా. సో therefore f of z is equal to 1 by z minus 2 is there, that is w minus 1 minus z minus 1 is w, therefore 1 by. So this is I will rewrite 1 minus 1 by w minus 1 by 1 minus w. చూడమ్మా, why I am writing minus 1 by w as it is. This is I am writing, actually this is plus, but 1 minus w I am writing 1 minus w. W minus 1 is 1 minus w, therefore negative sign. So therefore from this one, this is equal to minus 1 by w as it is and minus this 1 minus w is 1 minus w. This is again I want to write minus 1 minus w all to the power of minus 1. So therefore 1 minus w all to the power of minus 1 means what? This is equal to 1 plus w square plus w cube plus and so on. This is the way the function will go. So definitely here we write if w is less than 1 only, w is less than 1 and you see one more is important. This w is less than 1 okay, and this w is not 0, therefore w is not equal to 0. Okay, not equal to 0. So now you substitute the w value. So what you will get? 1 by w is equal to z minus 1 minus this is I will write as in the sigma notation. Sigma n runs from 0 to infinity. What is the w? Z minus 1 all to the power of n. Okay, all to the power of n. If 0 less than mod z minus 1 is less than 1. So actually this is the series, but we can also write this series as you see that here two series we will get was two functions. One is this function and the second one is this function. But an, bn, here a and bn both are same. Therefore, we can write in terms of one sigma notation. N runs from -1 to infinity. I will write this minus is there, minus is outside. I'm taking, and -1 to infinity. You see here z minus 1 all to the power of n. If 0 less than mod z minus 1 less than 1. See, ఏమైందమ్మా ఇప్పుడు you substitute -1, what happens? N is equal to -1, z minus 1 whole to the power of -1 is 1 by z minus 1. You are getting this. సో మనం ఇక్కడ ఏంటంటే ఇది చేసేటప్పుడు లారెన్స్ సిరీస్ రాసేటప్పుడు ద కండిషన్ యూ టేక్ 0 less than mod z minus 1 less than 0 less than mod z minus 1 less than 1 we are taking. So in this region the function is analytic. Therefore we are putting z minus 1 is equal to w and we are solving like this one. So 0 less than mod z minus 1 less than. The second condition is 1 less than mod z less than 2. This is we want to show. The second condition, given that 1 less than mod z less than 2, that is 1 less than mod z and mod z is less than 2. You see here from this one, can I write like this one? Mod 1 by z is less than 1 and mod z by 2 is less than 1. This is 1 by z, this is a z by 2 less than 1. So 1 by z is less than 1, mod z by 2 is less than 1. These are the two conditions. If satisfies, then 1 less than mod z less than 2. In between we get the Lorentz series and the function is analytic. So here how can we write this one? F of z as 1 by z minus 2 minus 1 by z minus 1 is a given series. This is I will write rewrite to in the form of 1 by here I will take this minus 2 is outside. Minus 2 తీసిన అనుకోండి ఏమవుతుందండి -2 బయటికి తీస్తే ఏమవుతుంది I am telling -2 not 2. -2 means this is minus z and this is plus 1 you are getting. That means 1 minus z by 2. Oh, sorry. So you see that mod z by 2 less than 1. So 1 minus z by 2. So mod z by 2 is less than 1, then this condition holds. Okay, 1 minus z by 2. This is the way we write it. Minus 1 by z is less than 1. This is also we want to take. 1 less than mod z means what? 1 by z, modulus of 1 by z is less than 1. Okay. So therefore, 1 by the second function I will write as you take z outside from this one, z into 1 minus 1 by z. I will take z only, I will take z minus 1. Okay. So therefore, this is equal to minus 1 by 2 into 1 minus z by 2 all to the power of minus 1 minus 1 by z into 1 minus 1 by z whole to the power of minus 1. By Lorentz series, we can write minus 1 by 2 this series is 1 minus x whole to the power of minus 1 times 1 minus z whole to the power of minus 1. 1 plus z by 2 plus z square by 4 plus and so on minus 1 by z into 1 plus this is 1 by z plus 1 by z square plus and so on. So this is holds for mod z by 2 is less than 1 and 1 by z modulus of z. So that's all. This is enough. You want to write the sigma notation, you can write. Otherwise, this is the series. That's all. Minus you take as a common 1 by 2 into 1 by 2 plus z by 4 plus z square by 4 to the 8 plus and so on. This is a one series and this is the one series and plus here you see 1 by z plus 1 by z square plus 1 by z cube plus and so on. This is another series. Definitely from this one mod z by 2 less than 1 and modulus of 1 by z is less than 1 means definitely it should be 1 less than mod z less than 2. This is the answer. So the next problem, expand f of z is equal to e to the power of 2z by z minus 1 whole cube about z is equal to 1 as a Lorentz series, and find the region of convergence. Region of convergence. Solution is very simple. So given that f of z is equal to e to the power of 2z by z minus 1 whole cube. So here we put z minus 1 is equal to w. Then z is equal to what? Z is equal to w plus 1. W plus 1. And the function f of z is equal to e to the power of 2z by z minus 1 whole cube becomes, you see here, this is we write as e to the power of 2 into z is equal to 1 w plus 1 by w plus 1 minus 1 w cube. Okay, this is equal to e to the power of 2 into e to the power of 2w. All right, e to the power of 2w by w cube. So by the Lorentz series expansion, we write f of z is equal to e square into 1 by w cube as it is. I will keep, and e to the power of 2w expansion is 1 plus x square by 2 factorial plus x cube by 3 factorial e to the power of x expansion. In the same way, 1 plus x is here 2w plus 2w whole square by 2 factorial plus 2w whole cube by 3 factorial plus and so on. This is, so definitely this is a e to the power of 2 into, in the sigma notation I will write n runs from 0 to infinity, 0 to infinity, 2 to the power of n, 2 to the power of 0 is 1, therefore 2 to the power of n, 2 square, 2 cube, 2 to the power of n by n factorial. You see that here 0 factorial is 1. Okay, here you see that 1 factorial is 1, 2 factorial, n factorial, 3 factorial like that one, and z minus 1 whole to the power of n minus 3. I'm writing in terms of w. You want to write first, you can write as w. W power n minus 3. If w is not equal to 0, this is the condition. From this one, we show the region of convergence. W is not equal to 0. So definitely this is e square into sigma n runs from 0 to infinity to the power of n by n factorial into z minus 1 whole to the power of n minus 3 if z minus 1 is not equal to 0. So not equal to 0 means z minus 1 is 100%, w is greater than 0. That is the region of convergence. E square into sigma n runs from 0 to infinity to the power of n by n factorial z minus 1 whole to the power of n minus 3 if mod z minus 1 is greater than 0. Greater than 0. So these are the some problems on Lorentz theorem. So now I will give some examples of Lorentz theorem for a homework. Find the Lorentz series expansion LSE for f of z is equal to z square minus 6z minus 1 by z minus 1, z minus 2, z minus 1, z minus 3. And z plus 2 in the region three less than mod z plus 2 less than 5. తప్పకుండా చేయాలండి ఇవి. Expand f of z is equal to z by z square plus 1 for mod z minus 3 is greater than 2. These two are the homeworks. So by this one, I am stopping the Lorentz theorem. The next class, I will discuss the singular points, singularities, zeros of the function, and also residues, residue theorem. By that one, I conclude this 15 unit. So any doubt, anything you want to ask, please. Yes, anything you want to ask?
No, sir.
No. So thank you very much. I'm stopping here on the class. Thank you.
Thank you, sir.